This will be the first of 4 videos on points of concurrency. And the focus of this discussion will be around the circumcenter. All right, so let's get started. The directions say to use our compass and straight edge in order to construct the perpendicular bisector of each side of the triangle below. So we're going to construct the perpendicular bisector of each side. And then it goes on to say, do this carefully and with precision. And what's going to happen if you do complete this task carefully and with precision, something really cool is going to happen at the end. So again, just be careful, make your constructions as precise as possible. So I'm going to go ahead and start out by constructing the perpendicular bisector of segment BC. And in order to do this, I'm going to make sure that the point of my compass starts exactly on point B. And because I'm going to be constructing 3 different perpendicular bisectors all within the same triangle, I may do all my constructions for segment BC in blue, and then do all my constructions for segment AC a different color, and all my constructions for segment AB a third color. But again, I'm going to make sure that I'm precise, that I don't change the compass setting in any way, shape, or form, that the point of my compass goes precisely on point C, so that each and every one of my perpendicular bisectors will be constructed with as much precision as humanly possible. All right, so there I'm going to go construct my perpendicular bisector for segment BC. And I might make this a nice big perpendicular bisector. Secondly, I'm going to go construct the perpendicular bisector for side AC. And this time when I construct my perpendicular bisector, I'm going to draw a nice big perpendicular bisector that extends quite some distance, really from both sides of the triangle, or through 2 sides of the triangle. And then lastly, I'm going to go construct the perpendicular bisector for side AB. Remember that in order to complete this construction, your compass has to be open to a setting that's at least half the length of the line segment, or half the width of the line segment. And again, if you have the option of doing different colors with your compass, I would highly recommend that, just because the fact that we're constructing so many different constructions within the same picture, it can get very busy at times. Ooh, and I did a very nice job with this construction. Now that I've constructed all 3 of the perpendicular bisectors of the sides of the triangle, I notice that they all happen to intersect at exactly one point. The one point where all 3 of those perpendicular bisectors of the sides of the triangle intersect is that red point right there, which I'm going to call point X. And what I think is really super duper cool about this is that all 3 intersect in exactly the same spot. We have a name for that, and the vocabulary word that you have to remember with respect to that point of intersection is called point of concurrency. So point of concurrency is going to be the point at which 3 or more lines intersect. Concurrent lines are going to be 3 or more lines that intersect at one point. So the perpendicular bisectors of the 3 sides of a triangle are concurrent lines because they all intersect at one point. Those three lines have what's known as a point of concurrency, which is the point at which those three or more lines intersect. Getting a little bit more specific still, the circumcenter is going to be the specific name for the point at which the three perpendicular bisectors of the sides of a triangle intersect. So in the picture above, the circumcenter would be point X. Now, the circumcenter has some really nifty properties that we're going to use to do some really cool or add some really neat things to our construction when you come back to class. But for right now, it's probably enough to know that the special property of the circumcenter is that it is equidistant from each vertex of a triangle. So in terms of our picture, what that means is that the distance from circumcenter X to vertex A is exactly the same as the distance from circumcenter X to vertex C, which is exactly the same as the distance from circumcenter X to vertex B. And again, I'm going to note this down here at the bottom of the page. Circumcenter X to vertex A is the same as circumcenter X to vertex B, which is the same as the distance, from circumcenter X to vertex C. And again, when you come back to class, we're going to add one more nifty construction to our picture. But for the time being, I think we've done quite enough and given you quite a lot to chew on here. All right, so as always, thank you for the gift of your time. I do want you to take some time to reflect upon what you've seen and heard and outline in your own words exactly what the key ideas and important understandings that you need to remember from this video are, and then see if you can apply your newfound knowledge to answer the questions at the bottom of the page.